Hello everybody and welcome to a new video on my channel, this time about setting up a demo cluster with Kubernetes, including some additional tools. What do I mean with additional tooling? Well, you can see it here. We'll deploy Nginx ingress controller to easily publish applications. We'll install the external DNS software to also automatically update DNS zone with a DNS record, the Flux Helm Operator to install Helm charts via Flux CD at the bottom there, which actually reads a Git repository and configures your cluster according to the configuration files it finds in that repository. Not on the slide, but I also deploy cert-manager, which can automatically provide certificates for applications we deploy, for example, via Flux CD. So let's take a look at what is needed for that. So basically what we'll do is we'll bring this all up into an Azure DevOps YAML pipeline, a straightforward pipeline with all the tasks one after the other. And we'll deploy the Kubernetes cluster, which is based on a virtual machine scale set, so not the standard availability set. That one also uses the standard load balancer, and will also deploy a public IP, which has to be also a standard SKU public IP, and so stock keeping unit or a standard type of public IP. We'll use that IP later to actually assign it to our ingress controller. Now, instead of actually going through all the steps in slides, I'll go through it in Azure DevOps. But before that, a couple of things about the Kubernetes cluster. So as I said, we use virtual machine scale sets here. We can deploy multiple node pools, although I'm deploying only one, as you can see there. We also deploy availability zones, or we deploy our nodes across availability zones. That's just for demo purposes. I don't actually need this in this environment. And we also make sure that's not in the ARM, in the JSON you see there, but we also deploy a standard load balancer, which gets created up front, which will also include a public IP automatically for outbound connectivity. That way the load balancer already gets created during the cluster creation. It will take less time for Nginx to be deployed and assign an extra IP address to that load balancer, because I've sometimes got timeouts when I'm not using that approach. When you're deploying a cluster this way, the networking type will be advanced automatically. So in this case, we do not link it to an existing virtual network, but a virtual network will be created automatically by the template. Now, if you look at the template, there's nothing too special going on. What you see here is in the deployment template. So what you saw on the slide as well, in the agent pool profiles, we make sure we set it to virtual machine scale sets. We turn on availability zones. We also enable auto scaling, but actually I didn't put it correctly here. So I basically turned it off, but in a revision or something I can add this or change this to like between 2 and 5 or something like that. But for demo purposes, I don't really need that. And then also very important here, the load balancer SKU is set to standard. Yeah. So it's a basic, quite a basic ARM template, nothing too fancy here. Maybe one thing you should know that we also deploy a log analytics workspace and then the container monitoring solution as well automatically, so we don't have to create that afterwards. So we get logging, metrics, etc., directly configured in the system. So that's quite easy to do here. Okay, that's the deployment of AKS. The deployment of the IP address is very simple as well. We deploy or we create a IP address of type static, just a v4 address, but important because we use a standard load balancer on the Kubernetes cluster. We have to also use an IP address of type standard and not of type basic. Otherwise you will get errors when Kubernetes tries to provision the load balancer or tries to configure the load balancer, that will be a problem. So make sure it is set to standard, right? Okay. Now, maybe before we start, what do all these add-ons do? If you have some experience with Kubernetes, you know what these do, but just for reference, Nginx ingress controller allows me to publish HTTP services using reverse proxy basically, and by creating what we call an ingress resource in Kubernetes, we actually configure this automatically at the Nginx level. With external DNS, I can actually specify that when I use a DNS name in my ingress resource, that DNS name automatically gets created in my DNS zone. I use my DNS zone at Cloudflare for this, and you'll see in a moment how this is configured. The Helm Operator is something special, which is actually used in conjunction with the fourth add-on here. The Helm Operator just allows us to install Helm charts using plain basic YAML. So we need a custom resource definition for that, which is something additional that is defined in Kubernetes to deploy a resource of a different type, and that we can use later on with FluxCD. And FluxCD is quite simple. FluxCD is software that looks at a Git repo, it looks at the configuration in that Git repo, and then apply that configuration to your Kubernetes cluster in a simple manner. I'm using that because whenever I want to add new applications to my demos, I don't want to modify the Azure pipeline. I just want to add some additional config files, YAML files to that Git repo and get it working right away. So that's what we are, well, why we are actually installing these add-ons. Then the fifth add-on, which is not on the slide, sorry for that, is cert-manager. That one can automatically provide a certificate to my application. I already have my application installed, so you'll see in a moment what that application is. Here, it's called real.baken.info, and as you'll see, so this is defined at the ingress level. We'll see that maybe in this video, maybe in another video. And automatically, by using cert-manager, we get a certificate from Let's Encrypt, so it's automatically available. So that's something, yeah, which is quite easy to do with Kubernetes, all automated, all in one step. Quite simple, really. Now let's look at the pipeline itself. Of course, you can edit the pipeline in your Visual Studio Code editor, but in this case, I'll just have it here. And you probably see I have a few failed runs. Typical. It's basically a game. How fast can you do it without errors in your pipeline? So let's take a look. It's quite a simple pipeline in this case. So it's just one stage, one big job, and then all kinds of tasks within that job, right? I won't go into all the details, but as we said, we're going to deploy our AKS cluster first. So we have we give it a name, for instance. So we override some parameters in the ARM template, and we specify the password of our service principal. That one is defined here at the variable level. So it's a secret variable. So this is a simple ARM template deployment, the one I showed earlier in the video. Then we deploy the IP address. In this case, we provide the IP address with a name, which is coming from this variable over here. And we also specify that we want an output. Maybe that's an important one to realize. You see here in the definition of the IP address ARM template, we say, well, what should the output be? The output should be the IP address that gets provisioned. And we actually make sure that the ARM template outputs that IP address after creating the IP address. So ARM outputs, this one that you see here will actually be a variable that I can use in next steps. But yeah, the output is JSON, and I want the IP address, which is somewhere buried within the JSON in the IP address value. We want to basically take it out. How do we do that? We simply use a bash script. We echo the complete JSON output and we pipe it through JQ. And JQ is a tool that allows you to then dig into JSON and extract variables or data. So we extract the IP address .value, and that we set that value as a new variable which we call test IP. So later, in later steps, we can use $ and then parentheses test IP to actually refer to the IP address that got created here by this ARM template using the ARM output. Then we do a couple of simple things. We install Kubectl 1.14.8. We match the cluster version. We install Helm v3. Azure DevOps supports Helm version 3 right now. Just use the latest. You'll get the latest spec, which is indeed version 3. Then we need to run a couple of scripts. I want to access my cluster or actually configure Kubectl, the Kubernetes administration tool, with correct credentials. We do that with an Azure CLI command as AKS get credentials. That way, on the agent that is running these tasks, we have this set up correctly. Then we add a couple of repos to Helm because we're going to install all our add-ons using Helm, and yeah, the Helm charts are in those repos, and they're not by default added to the Helm installation. We update the repos, and then we have to apply a couple of YAML files in this case, or we do that here. We have chosen to do it like this. So we install the custom resource definition for our Helm releases, and we install a couple of custom resource definitions for cert-manager, things like a certificate request, an order, and so on. These are all new types that get defined using these custom resource definitions, and they're used by cert-manager to do all the certificate magic, basically. Now, for Flux and cert-manager, we need a namespace. We just use a Kubernetes task here. The Kubernetes task, as you can see, can be configured with inline configurations. Basically, that's the YAML we want to apply. And we do it this way because if you do Kubectl create namespace, yeah, you'll get an error if the namespace already exists. With this apply, we actually don't get that error. So we do this for creating the Flux CD namespace and also the cert-manager namespace. And then it's simply deploying all the add-ons using Helm charts. So here we deploy Nginx, and the only thing we do really is make sure that the IP address of Nginx, of our ingress controller, is set to the IP address that we provisioned earlier using an ARM template. So that $test IP reference I talked about earlier. I also set in the Helm chart this setting, controller publish service enabled is true, to get it to work better with external DNS, and the other one we won't discuss right now. So that's basically it. That way you install a basic Nginx deployment, which is fine for demo purposes, on Kubernetes. Next is external DNS. Again, simply a Helm chart, and we use the Helm chart deployment task to do so. But in this case, we need to provide values to configure external DNS to work with my Cloudflare provider. We do this in two ways. First of all, we deploy or we use a values file to give it to Helm during deployment, and we override one of the values by setting it here in the override values option, because the token shouldn't be in a file, of course. The token in this case is again a secret variable at the Azure pipeline level. Now the values YAML file is nothing too fancy. So if we go to external DNS, values YAML, we just set the provider to Cloudflare. We set the interval to check for new ingresses to every minute. That's handy for demos. We don't have to wait 5 minutes. And in my case, I only allow bucket.info DNS names. So we provide this value file to the Helm deployment with this parameter here. Next, we deploy the Helm Operator. Again, nothing fancy. It's just a Helm chart, which provide a couple of extra parameters to set Helm version 3. And we also refer to the pre-release of Helm Operator, the latest one I could find at the time of this video, which is v3 dev and so on. So that's something that I do in this case. And we deploy it to the namespace flux cd. We deploy Flux as well to the namespace Flux cd. And in this case, we set a value of git.url. We set it to this thing here, which is what is required by the chart. So git at github.com, because I'm using Git and I'm using github.com in this case. You don't have to, but I'm doing it here. And then the git URL is defined up top, gebake demo clue flux, which actually refers to this repository, which is a public repo you can go to. And that public repo contains all sorts of configuration files that we will use to deploy resources to our Kubernetes cluster using Flux, right? So that's basically a very simple thing that is done here. So that's what we were at here at Helm deployment of Flux. And at the end, we deploy cert-manager. And when cert-manager gets deployed, we can also do all kinds of configurations to get these certificates to work. Yeah. So it's not a complicated YAML pipeline at all. I will provide links to the pipeline on GitHub, so you can actually use it in your own projects or for your own demo purposes. But let's see what happens when you run this pipeline. I won't run the pipeline here now because it takes too long to run. But if you go to one of the previous runs that succeeded, which is the last one, right? You see here that we have it's called deploy demo cluster. We have one big job. As you can see, deployment does all of these steps. Now, the first time you run this deployment, this one here, which deploys AKS, that can really take a long time. So I've seen that it can sometimes get a bit stuck on the network configuration, and it's not uncommon to see 10 minutes, 15 minutes, sometimes even in worst cases 20 minutes here. But yeah, it depends a bit on when you run it and on the circumstances. I can't quite put my finger on it, but this can take a really long time. It doesn't take a long time now because I have rerun the pipeline after the cluster was already created. Now the question is, what gets created? I'll just take a look at the Azure configuration here. In another video, I'll take a look at what we actually deploy at the Kubernetes level, right? But here on Azure, what gets deployed? Well, very simple. Our cluster gets deployed. The cluster is deployed. And we can clearly see it's a cluster that supports multiple node pools, of which I have only one. The version that we specified, only 2 nodes in this case. Okay. The networking is indeed the type advanced. Yeah, that's basically all we need to know. Yeah, insights as well gets configured automatically. So we directly get insights with Azure Monitor, and we can see here what happens. And if I go, for example, to containers and deployments, I can see what's going on there as well. This cluster already had my the Git repository connected to the cluster. So everything which is defined here, like for example a Helm chart which installs InfluxDB, gets applied to the cluster. So you can see that here there's InfluxDB is running, container is running for a while already, and it's doing its stuff, and all the other ones you can see here as well. A custom application I've deployed, a real-time application. That was the one that you saw over here. That all gets deployed by Flux, but we'll look at that in another demo. Now, in the backend, of course, because this is just our cluster object, but if we look a little bit deeper in the resource group, you'll see that you also have the log analytics and the container insight solution deployed by our template, so that's fine. And in the backing resource group, so this is the one that gets created to have all the stuff handled. What we see here is that indeed we've deployed a cluster based on virtual machine scale sets. Also, this VNet got deployed because it's advanced networking, and if you don't specify a network, it will create one for you for demo purposes. That's of course fine. And then my IP address got created as well. The IP address is of type standard, so we see that clearly over here, and that's the IP address. And that IP address automatically is part of a front-end IP configuration that you'll see over here. Yeah, this is the one, and that's actually tied to my Nginx deployment. So this one here, 51 and so on, 232 in the back. If I go to my cluster, reconnect my Cloud Shell, I think I'm in the correct namespace already. So I'm doing kget svc. What you'll see here is, no, I'm not in the correct namespace, so I'll switch to the kube system namespace. Check the services, and as you'll see here, this IP address, that's the one matching the one over there. And indeed, when I go to my application, this here, real.baka.info, is actually ending up there as well. So if I ping real.baka.info, that will also nicely match the IP address of the Nginx ingress controller. And this record automatically got created by external DNS in my Cloudflare hosted zone. Okay, that's it for now. Thanks for watching. And in a next video, we look a little bit deeper into what gets deployed at the Kubernetes level. Thank you.